This video is going to be the first in a new series of EFI and engine management tutorials and theory videos that I'm going to be doing over the upcoming months. I'm going to try to do 2 videos a week, and what I want to do is I want to unpack what EFI is, what engine management is, and take all of these big concepts and turn it into something that you can easily understand. Each of these videos is going to be pretty short, and I'm going to try to take some big ideas and break them down into bite-sized chunks so that you can process them and understand them and ultimately apply them to your project car, your race car, your street car, whatever it is that you're building, that you're tuning, that you have going on. First thing I want to do is I want to address what is EFI. EFI is electronic fuel injection. For a lot of guys in the car space, they're very, very used to carburetors with jets and venturis and mechanical metering devices. EFI is a system that accomplishes those same things by using electronics to very precisely meter the amount of fuel that goes into an engine. Surpassing electronic fuel injection, complete engine management is the complete control of an engine, including fuel and spark, occasionally air, and other functions such as EGR, blow-off valves, waste gates, two-step, nitrous. Anything like that that the ECU is controlling is part of the complete engine management package. In this series, I'm going to start with fuel because I think that's probably the most complicated and also most overwhelming part of engine management. And then we'll move on to ignition control, transmission control, and eventually a few other advanced topics. So how does EFI work? You have hardware and you have software. The hardware is everything that is physically on the car. So that starts at the fuel tank. The fuel tank holds the fuel and is also typically baffled to make sure that the fuel pickup cannot come uncovered when you're cornering, when you're accelerating hard. In EFI, having fuel supplied at all times is pretty critical, so you want to have a really good fuel tank. The fuel pump pushes fuel from the fuel tank through a fuel line up to the engine to the fuel rail. The fuel rail is typically a piece of aluminum or stainless with bungs on it that support the fuel injectors. So the fuel rail delivers fuel to the fuel injectors. Fuel injectors are essentially a small valve that sprays fuel into the intake or into an intake runner onto the back of a valve, or in the case of direct injection, directly into the combustion chamber. Fuel injectors are electronically controlled. So they have an electromagnet inside of them, and the computer supplies power and ground to them to open and close them at the right time and supply the correct amount of fuel. After the fuel rail, fuel pressure flows to the fuel pressure regulator. The fuel pressure regulator creates a high side of the system, which maintains constant pressure or maintains pressure that is referenced to manifold pressure, so that if you're running boost, you can increase pressure with boost and maintain the same pressure differential. We'll cover that in much more detail in a later video. But the fuel pressure regulator maintains a high side with constant pressure feeding the fuel injectors so that the ECU knows how much fuel the injectors are going to deliver at all time, and any excess fuel is bypassed and returned to the fuel tank. Additionally, you have the computer itself, the ECU, engine control module, or PCM, powertrain control module, and you have a variety of sensors on the engine that are feeding information to the ECU, to the computer, so that it can make the best decisions at all possible times. These are the main components of fuel injection. When you get into boost and you get into other things, there are additional components, but for simply controlling fuel accurately in a naturally aspirated engine, these are the main components that you need. The computer will be reading information from a few sensors: the intake air temp sensor, which literally tells it how hot the air is, and from that the computer can determine how dense the air is and how much oxygen should be in the air. An oxygen sensor in the exhaust, which tells the computer if the mixture that has been burnt in the engine is rich or is lean, and allows the computer to make some adjustments to the fuel mixture in real time. You have a coolant temp sensor, which tells the computer if the engine is fully warmed up or if it's cold. And you have a variety of other sensors, throttle position, that allow the computer to interpret data and make good decisions to provide a smooth running. On the software side of EFI, you have a lot of controls. You have layers of control that allow a tuner to make adjustments and to dial in an engine by targeting specific parameters that affect certain running and operating conditions. Two big ideas in EFI are open loop and closed loop. Open loop is the idea that the computer is pre-programmed how much fuel, how much spark to put into the engine at a certain time depending on sensor readings. Closed loop is the idea that the computer, when in closed loop, can see the sensor readings, can see what it's supposed to be commanding based on pre-programmed information, and if it's not getting the readings that it wants, particularly if it's not getting the fuel mixture reading it wants from the oxygen sensor, it can slightly richen or slightly lean out the mixture in real time. So they call that open loop because there is no feedback loop from computer to adjustment. The computer's not making any adjustments from what it's programmed to do. And a closed loop, where there is a closed feedback loop and the computer sees data, reacts to data, sees what that did, reacts again, constantly chasing the best possible operating. Additionally, a final concept that I really want to leave you with is the idea of volumetric efficiency. Volumetric efficiency is the measure of how much air is in an engine relative to its displacement. For example, if you had a very large V8 at 8 liters, and you had 100% volumetric efficiency at 6,000 RPM wide open throttle, you would be able to say that at that point, 6,000 RPM wide open throttle, 8 liters of air are entering the engine, and that is 100% volumetric efficiency. Similarly, if you're at 3,000 RPM and you have 50% volumetric efficiency, that means that 8-liter engine is only consuming 4 liters of air for one complete combustion cycle. 25% would be 2 liters of air for one complete combustion cycle, and so on. This idea of volumetric efficiency is a really important metric in most EFI applications, especially in the aftermarket world, where you're using volumetric efficiency as your base measurement to determine how much fuel to add to the amount of air that's supposed to be going into the engine. I'm going to wrap this video up right here with a real quick recap. EFI is the electronic, computer-controlled metering of fuel into an engine to maintain proper running conditions. Complete engine management goes further and includes ignition control, includes control over any other engine features, whether they be emissions related such as EGR or performance related such as a blow-off valve or a wastegate on a turbo. You have transmission control as part of powertrain control, and you have a bunch of other possibilities that are almost endless depending on what kind of EFI or what kind of engine management scheme and system that you're running. You have some basic fuel hardware that is really essential to making sure that fuel is delivered properly to the engine, and you have an entire array of sensors feeding information to the computer so that the computer knows what to do at the right time. You, as the tuner of an EFI system, have the ability to adjust a lot of parameters which can make an engine run better or run worse, and it's up to you to learn this theory so that you can do the best job programming that. Open loop in a EFI system is where the computer commands fuel based on what you as the tuner have told it. And closed loop allows it to make real-time adjustments to what you have tuned based on sensor readings. Volumetric efficiency is a really important measurement of air as it goes into an engine, and it is essentially how full of air the engine is in one complete combustion cycle at any given RPM. And volumetric efficiency is essentially what percentage of an engine's displacement is it consuming in air per complete combustion cycle at any given engine operating condition. I hope you enjoyed this video, and I hope it was helpful. In the next video, we're going to get into a lot more fuel injection theory. We're going to talk about what the computer is really doing how the fuel injectors are controlled, and how that affects the overall tuning experience for your base fuel table in a typical EFI application. Thanks for watching.